Okay, so this is our Perpetual motion machine. We made it out of 2 plastic stone molds with 8 pieces of cardboard divided up, and then 1 cylinder.
Dowel or something?
Yeah, I don't know.
Dowel. Yeah.
It's like a one dowel.
Yeah.
With a pin at the bottom, and inside there's about 8 marbles inside each little section divided off with the cardboard.
So the goal of this project was to make a machine that was as close as possible to perpetual motion, and some of the issues we had to focus on were how to reduce friction, and how to limit the amount of energy lost. So to reduce friction, we made the pin really small at the bottom because it has less surface area, which has less friction overall on the whole device. And because it's made of metal, it's like a material that has less friction than like wood would have had if we had just left it like that. So this project will help us understand in the real world how to do things like make a fuel-efficient car engine, because cars are always under forces of friction from the road and air resistance as they travel through air. And the ideas on the concepts behind conserving energy will help us to apply this in the real world.
So for our observations and conjectures, we noticed that when we first built this device, we didn't have a pin at the bottom to spin it on, and we only had about 5 marbles in each section rather than 8, and it didn't move as long. We only got it for about 56 seconds. So then when we added a pin to the bottom to reduce the surface, and when we added more weight in, we noticed that we got it to move longer, and then the faster we started the project off, the longer it moved for.
So for the physics behind our project, the weight of the balls inside of the wheel thing as they spin adds to the overall device's acceleration, because the balls want to keep spinning and keep pushing the little dividers around, which keeps the whole wheel turning. And also the momentum of the balls on the inside also adds to this force. And like we said before, the pin at the bottom having the lowest amount of friction possible reduces the amount of energy lost as the wheel turns on the table.